Okay.
Good evening, students. This is Sandhya. I teach physics. Today I would like to discuss motion in a straight line, important points and previous year's questions. So the topic is motion in a straight line. So let us see what is the topic overview, weightage and what to expect in this session. Today I would like to discuss motion with uniform acceleration and non-uniform accelerated motion. This is the overview of this session. Non-uniform accelerated motion. And weightage of this chapter, compulsory 2 questions, means 6.6% weightage from this chapter. What to expect in this session? We discuss all important points and shortcuts, means short tricks, and previous year's questions. So today we will have the discussion about motion with uniform acceleration and non-uniform accelerated motion. And the weightage of this chapter is 2 questions, 6.6% of this chapter, and these are the key points that we are going to discuss. So you can download the Spark Academy app for great discounts on your courses. Here are the courses. In this app, free handwritten notes. You will be having the free study material, free tests, and previous year's questions and free mock tests will be conducted. So let us start the topic. So first, to describe the motion in one dimension. Motion in one dimension means which follows the straight path. We need some quantities. That quantities are velocity, speed, acceleration and distance, displacement. These are. So let us see all basic points and then we go to the shortcuts. So average velocity can be calculated by taking total displacement by total time taken. Here displacement is nothing but change in position by time taken. Means the final position minus initial position by time taken. Instantaneous velocity means when time tends to 0 at a particular instant. Displacement by time taken is called instantaneous velocity. And average speed, total distance by total time taken. This also we write it as delta S by delta T. The difference, the mathematical expressions are same. Velocity is a vector quantity and speed is a scalar quantity. So we need to follow the rules of vectors by following the vector directions. Here we can find the velocity. So we have to follow law of vectors mainly to find the velocity and the instantaneous velocity. And the instantaneous speed, same as like instantaneous velocity at a particular instant. The distance by time taken is called v instant. We can write it as ds by dt. If object is moving in one dimension, means if it is moving in a straight path, instantaneous speed will be equal to magnitude of the instantaneous velocity in a straight line motion at a particular instant. Magnitude of instantaneous speed will be equal to magnitude of instantaneous velocity, that is ds by dt. These magnitudes are equal because they are following same direction, and we need to follow, to find the velocity, we need to follow the sign convention by following the law of vectors. If object is in one-dimensional motion, if the path, line of motion is this way, initially line of action from where, for example, object started from here, this initial action need to take it as origin, and this side, then the path will be, line of motion will be this way, straight path. And rightward we need to take it as the distances or velocity, we need to take it as positive, and left side we need to take it as negative. So sign convention need to be followed. Here there are vector quantities. If the line of motion is this way, upward distances we need to take it as positive, downward negative, and the line of motion is this way, in this direction positive and downward will be negative. So we need to follow law of vectors. Okay. Next quantity is average acceleration. Average acceleration is nothing but change in velocity by total time. Change in velocity means final velocity minus initial velocity by time taken. So we need to, while finding the acceleration of the object which is moving in a straight path, we have to solve that as vectors by following vectors. See here, delta V we are given with final velocity minus initial velocity. A velocity is a vector, so final, this can be written as final velocity plus velocity, initial velocity vector, negative vector we need to take. So by following, you need to solve the acceleration by following the law of vectors. And next, instantaneous acceleration at a particular instant in its journey, change in velocity by time taken. And instantaneous acceleration, when velocity is given as a function of time, differentiating this with respect to time, we can find the acceleration at that instant. If we are given with velocity is a function of s or x, s or x representing the distance. So if it is given as a function of distance or displacement, we can use v into dv by ds. So if it is a function of x, first we need to differentiate this with respect to that position s or x. We need to differentiate with respect to that position and multiply it with the velocity. Then we get the acceleration. This concept is very important. To find the acceleration, when velocity is given a function of time and velocity is given as a function of displacement. So when function of time is given, use this. When function of displacement given, can use this. Next, so now we have entered our important topic. So mostly we get the confusion while finding the distance, speed, displacement and velocity when object is moving with uniform acceleration. See here, these are the standard equations of motion we can apply when object motion with the uniform acceleration. Uniform means constant acceleration. To find the velocity after some time, we have u plus at, and the displacement equation we have ut plus half at square, and third equation of motion, that is v square minus u square is equal to, when we are given with the final velocity. So to find the acceleration or displacement having different velocities, we can use this equation. And nth equation, that is distance at a particular second, third second in its journey at a particular second. To find the displacement, we have nth equation. Sn can be written as, Snth can be written as displacement in n seconds minus displacement in n minus 1 second. This gives the Snth displacement. Okay, nth displacement can be calculated by using this. So what are the quantities? The values v, s, u, t, a. V is final velocity, U is initial velocity, A is acceleration, S is displacement, T is the time interval, and nth is displacement in the nth second. And we have one more equation to find the average velocity. When object started with velocity u, in a time t, it gains the velocity v, then the average velocity can be calculated by using u plus v by. This will be the average. So v average is nothing but v average velocity of the given interval. So in a given interval of time, average velocity can be calculated by using this result. Here also, while working with the numericals of motion with uniform acceleration, we need to follow the sign convention. Compulsory, we must follow the sign convention because v, u, acceleration, displacement, these all are vector quantities. So the line of motion, so initial action or initial point from where action started, that point is taken as origin, rightward positive, leftward negative. Again reminding this sign convention, this is very important. So here we have one situation related to motion with uniform acceleration. So let us see a ball thrown vertically up from the ground. This is the ground. From here it is projected vertically up with u. So it reaches certain maximum height, and after some time again it moves down. So for this case, for ball thrown vertically up, what is the maximum height reached by the ball and what is the total time taken by the ball? Means here we can use these equations of motion with the sign convention. Then maximum height we can find by using u square by 2g, because when it reaches maximum height at the highest point, its final velocity becomes 0. So we can use this equation. So this is the origin. So follow the sign convention. Line of motion is like this. So if we are taking distances upward, those will be positive, downward will be negative. Okay, so u will be positive, and acceleration, it moves down due to gravity. So acceleration due to gravity for vertically thrown up case, we can write it as minus g, because it is, the direction is showing downward. So a is minus g, u is u only, u is plus only, and v becomes 0. And h we need to find. So s is nothing but h. So by using this equation, put 0 here. This equation becomes 0. Minus u square is equal to 2 into minus g into, where s is the maximum height reached. So height reached means from origin to highest point we calculate the h. So that is positive only. So both side minus gets cancelled. H will be equal to u square by 2g. That is the maximum height reached by the ball when it is thrown vertically up. And what is the total time taken? So here, time of ascent, which is the time taken to reach the highest point, and time of descent, which is the time taken to reach the ground. So total time is time of ascent plus time of descent. We can write it as u by t plus u by t. So the total time taken for a vertically thrown up is 2u by t. This is the situation how to apply the sign convention with these standard equations of motion. So the required quantity we can find easily. They are asking maximum height for this case, total time of the motion. Okay. Next, Next, one more concept, graphical representation questions. These are very important. You must look into velocity time graph questions for constant acceleration. And here we are given with position. We are given with the position time graph for constant acceleration. Means position is taken on y-axis, time on x-axis. For constant acceleration, here initially it is the initial position of the object. As time passes, the graph shows like this. This graph is indicating positive acceleration. For example, position is taken on y-axis, time is taken on x-axis, and initially the position of the object is here. As time passes, the graph shows like this. Here parabola opens downward, here parabola opens upwards. Here acceleration is less than 0. So it is negative acceleration. Means velocity, if you take the slope of this graph, if we are taking slope of position time graph, what it gives will be equal to velocity. Means at any instant in the graph, y component by x component gives, that is x by t value gives velocity at that point. So if we observe this graph, it is showing negative acceleration. Velocity is slowly decreasing. So velocity decreasing means acceleration is negative. It is called a retardation. And here this graph shows a parabola open upwards. It is positive acceleration. Velocity is increasing. If you take the slope of this graph at a particular point, that slope gives velocity. So as it is increasing, you can say this graph is the positive acceleration. If they are asking by giving the position time graph, if they are asking what is the final position of the object, so here we have the equation to find the position. We take the displacement equation, which is equal to change in position, final minus initial position, is equal to ut plus half at square. And from this we can write final position will be equal to initial position plus ut plus half at square. It moves with constant acceleration. It will be given in the question, and you can find at that particular point by taking the slope, you can take the velocity. So at that position. Okay. So for that particular position, you can take the velocity and can find the what is the final position of the object by using this equation. More than this graph, velocity time graph for constant acceleration questions are very important. Here we have the equation to find the velocity after some time. We use v equal to u plus at. And if you are taking, means the graph is velocity is taken on y-axis, time is on x-axis. Object is started from rest, means the graph shows like this, straight line. So it is increasing as time passes, velocity is increasing. So it will be the positive acceleration as velocity is increasing. When body approaches, acceleration will be positive. Always keep in mind. When body approaches, acceleration will be positive. When body comes to rest, acceleration will be negative. Means comes to rest means velocity decreases. So negative acceleration, that is called retardation, you can find. So if we are taking the slope of the velocity time graph, so at this particular point, if you are taking y component by x component, that is v by t, slope of the vt graph gives acceleration. About velocity time graph, now by giving the graph like this, there are two variations in these graphs. Object started from rest and it accelerates with a constant rate for some time, and decelerates, finally come to rest. These type of graphs you need to look into various problems about these type of graphs. This is one of the important graph about velocity time, and we can ask the question this way also. Object started from rest, accelerates uniformly for some time, and it moves uniformly. It is in the uniform motion, means velocity remains constant. Showing the straight line constant. Here it is accelerating and it moves with uniform motion, and for some time it decelerates. Finally it comes to rest. These two graphical representation questions you need to practice. Very, very important. So by giving these type of graphs, they can ask find the area under the velocity time. They can ask find the displacement of the object. By giving velocity time, they can ask find the displacement of the object. So you have to take area under the velocity time graph is the displacement. So these two variations of graphs you need to practice. So graphical representation questions are also very important. So let us see. I would like to give short tricks from the uniform accelerated motion cases and non-uniform accelerated motion cases. So here, first let us discuss uniform acceleration cases. So we have mainly three equations. V is equal to u plus at, s is equal to ub plus half at square, and v square minus u square is equal to 2ax. Here, if we are given with started from rest, object started from rest. So these equations we can modify into shortcut. That shortcut forms we can use to find in both the cases, when object started from rest or when object started with some velocity and finally comes to rest. In those cases you can apply these short tricks. So started from rest means initial velocity 0. So we have equation for to find the final velocity. We have two equations, that is v is equal to at from this, and next v is equal to, from this put u0, you will get 2ax. So for velocity, to find the final velocity we have two equations, and next to find the distance traveled. Here also we will be having two shortcuts. S is equal to half at square and s is equal to v square by 2a. And next they can ask what is the time taken to reach the to travel the distance. So for time also we have the two equations, that is t is equal to v by a and t is equal to, we can write it as 2 into total distance travelled by acceleration. So these are with the uniform acceleration cases, a remains constant. So if we are given with the object started from rest, u, its initial velocity is 0. So we have for velocity two equations, to find the distance two equations, to find the time two equations. These results are very important results to solve the numericals about the free fall object and vertically thrown object. See, these same equations we can write for finally, if object finally comes to rest. If it finally comes to rest. Finally comes to rest means its final velocity becomes 0. Then to find its initial velocity, with which velocity it is started, if they ask the question. So these same equations we can write like this. U is equal to at. These same equations can be written like this, and u is equal to under root 2as, and we have to find the distance This equation will be same only, half AB square, and S will be equal to, here we need to take U square by 2A. So to find initial speed, we have two equations. To find distance traveled, two equations, and to find the time in this case when body comes to rest. So here it will be equal to U by A, and T will be equal to under root 2 into S by A. So here we discuss with one example in the next slide about these cases. So these are the main equations to find velocity, distance or displacement and time taken. An object started from rest or finally comes to rest. These are quite important results to solve the numericals. And next, let us see non-uniform accelerated motion. How to find the acceleration, displacement, velocity and acceleration for the non-uniform accelerated motion. So we are finding the displacement. When velocity is given as a function of time, then differentiating the displacement with respect to time, we get velocity. Here what we have done, differentiation. So using calculus method, for non-uniform accelerated motion, we can find the displacement, velocity. So here differentiation, we get velocity. If velocity is given as a function of time, and to find the acceleration, we differentiate that velocity with respect to time, we get the acceleration. This is acceleration. Now, acceleration is given as a function of time. So using calculus method, by the integration, we can get the, here we are using integration. Or velocity is given as a function of time. To find the acceleration, we are following differentiation. Acceleration as a function of time, to find it, we follow the integration. And here also, velocity is given as a function of time. It varies with the time. By following the integration, we can find the displacement. Because this v equal to ds by dt can be written as like this. So by integrating this, we can get the displacement. So here integration. So mainly uniform acceleration cases, non-uniform accelerated motion. So these points you have to remember, and to find the displacement, velocity and acceleration, these relations you have to remember. Okay. Now, one more concept is there. Let me explain clearly. Relative velocity. About relative velocity in one dimension, they can ask the questions. So, if any two objects are following in the same direction, velocity of object A with respect to B, A is following positive direction, B is also following the same direction. Then, relative velocity of object A with respect to B will be VA minus V. If they are in opposite directions, if V is like this, VA is like this, VB is in opposite direction. If they are ahead each other, then velocity of A with respect to B will be VA plus V, because VA minus of minus VB becomes VA plus V. So these tricks you need to remember about these cases. So the link in description it is there. You can follow this, you can call this number to get the admissions. Admissions are open, and there is an online coaching and offline coaching. Classroom coaching is also there. There are daily on demand live sessions will be there. Yeah. So what is our methodology get the good score in exams for the students, we follow the basic concepts. Means we start with the basic concepts, shortcut methods or model questions, exercise questions, previous year's questions, and chapter-wise tests. Every weekend test, grand test, and test analysis will be there. So now we follow the previous year's questions. So mainly, let me give you what are the typical questions you need to practice. They can ask the questions, find the distance or displacement when object change the direction. For example, object travels a distance from A to B and again reach to point C. In this case, or it reaches to point A. In this case, if they are asking the distance, you need to take actual path length. If they are asking displacement, in this case, it started from A, reaches to B, and again come to its initial position. So displacement will be 0. Those type of questions you have to concentrate. And velocity time graph questions. And third, find the acceleration. How to find acceleration when it is acceleration equal to what? When position is given as a function of time or time is given as a function of x. Here we follow the calculus method. So these three you need to follow for your final exams. Yeah, see here we are given with a particle is moving with the speed, the previous year's question. V is equal to B root x along positive x axis. Calculate the speed of the particle at time t is equal to tau. Assume that the particle is at origin at t is equal to 0. So when it is started at t equal to 0, it is at the origin. So given speed v is equal to b root x. So using calculus method, it is a function of displacement. So we follow the calculus method. So v can be written as dx by dt. That is equal to v at root x means we are writing it as x power 1 by 2. Now it can be written as x power minus 1 by 2 into dx. So when velocity is given as a function of displacement, first we are finding by integrating the value, we find its displacement. After if you differentiate that, you can find the speed of that particle that we are finding. So taking x power 1 by 2 this side and d into dt, this will be equal to yes. So integrate on both sides, then we get integration of x power minus 1 by 2 dx is x power 1 by 2 by 1 by 2 is equal to b into d. So from this, find the position first or the distance. X will be equal to, actually x power 1 by 2 means root x. So then x becomes b square t square by 4. 1 by 2 will come this time. Now differentiate with respect to time, because you need to find the speed of the particle. Then dx by dt will be, which is the velocity or speed, will be equal to b square into 2t by 4. Here t is equal to tau. They are asking speed of the particle at time t is equal to tau. So we can write it as b square, put the t value tau, tau by, it cancels 2 times by 2 will come. This is the answer. So option B. The next question. A particle is moving eastwards with a velocity of 5 meter per second. In 10 seconds, the velocity changes to 5 meter per second northwards. So initially, it is 5 meter per second eastward, and in 10 seconds, time taken is equal to 10 seconds. Velocity changes to 5 meter per second northwards. So they are asking find the average acceleration. Acceleration is nothing but change in velocity by time taken. So while finding the acceleration, we need to follow the law of vectors. Change in velocity means v2 minus means a final velocity minus initial velocity by time taken. So this can also be written as final velocity plus minus vi. So by following the vector notation, just draw the directions: east direction, north direction. So here vi is 5 into I cap, that is initial, and v final is 5 into j cap, it is showing upward. So as per the direction of the vector, we need to take minus vi. Minus vi means this side. So resultant of these two, resultant magnitude of these two vectors will be the direction of change in velocity. So here change in velocity is final velocity plus of minus initial velocity. Even they are asking the direction also. So what is the resultant of these two? By following vectors, this is vi, but we need to take minus vi. Then we can find the magnitude of that resultant. That is the change in velocity direction. So what is this direction? This is northwest direction. So now find delta V first. So these two are being perpendicular to each other. So under root vi whole square plus vf whole square plus 2 v1 v2 cos 90. So it will be equal to, here we get minus by following the subtraction of this factor. So we can write it as minus. Anyway cos 90 is 0. Here we can write 5 whole square plus 5 whole square, which will be equal to 50. The root 50. So here it can be written as 5 root 5. Sorry, 5 root 2. This is the velocity, but acceleration we have to take that 5 root 2 by time taken is 10. So it is 1 by root. It cancels, root 2 can cancel the 2, root 2 times. So 1 by root 2 meter per second, direction is northwest. Next. A car covers the first half of the distance between two places at 40 km per hour and other half at 60 km per hour. The average speed of the car. So car initially, in the first case, its initial so actually the distance traveled, actually it is traveling between the two places. Let us say the two places A and B. The distance traveled, take it as like x. First half of the distance means x by 2. Next half distance x by 2. What is the speed between the two places? First half of the distance with 40 km per hour. Here 60 km per hour. Now they are asking what is the average speed of the car. Average speed means total displacement by total time taken. Displacement by time taken. What is the total distance or displacement? Here it is x. Total time is, here time taken, let us say t1, and the next half journey t2. Total time taken will be t1 plus t2. t1 is equal to, we are given with the distance and the speed. So we can write it as like v is equal to x by t. From this t will be equal to x by. So we can write x by 2 into 40. t2 will be equal to x by 2 into 60. So here total time taken, we can write it as x by total time we have to write 2 into 60, which is equal to, take common ends, it gets cancelled, and you can take common 1 by 20, so it goes up, and take LCM, here 4 remaining and here 6 remaining. After taking LCM, 4 into 6 by, it is 6 plus 4, which will be equal to 20 into 4 into 6 by 10. So 2 times 24, 2s are 48. This is the average. The given options, all options in kilometer per hour only. That is what we did not convert these speeds into meter per second. So average value is also given in kilometer per hour. So you need to be careful with the options also. The given values might be given in one system, options will be in the other system. So before substitution, you need to look into that. Next, here we are given with velocity time graph. Velocity and time graph of a body in a straight line motion is shown in the figure. The point S is at 4.333. So this point is 4.333. So can I write after 4 means like 0.3. 0.33 means it is, this distance is 1 by 3, that way. The total distance covered by the body in 6 seconds is. So to find the distance, when we are given with the velocity time graph, we need to take area under the graph. Area under velocity time graph is equal to distance covered by the object. So hence distance is equal to, now we are taking area under this graph. So here we are taking this area first, that is OABS. So area of OABS, it is like a trapezium. Next, as it is a distance, no need of directions, and take area of SCD. Okay. Now, area of for finding area of OABS. So first we are taking this base OS value. So OS is nothing but 4 plus 1 by 3. It is not exactly at 4, so you need to add this point also. So it will be 13 by 3. And this SD will be equal to, this distance will be equal to, means in the sense on the axis time is given. So this value will be equal to 6 minus 4, 2, till here 2, and need to subtract this portion. So 2 minus 1 by 3. So it will be equal to 5 by 3. Now consider the area of OABS plus area of SCD. OABS is a trapezium form. So it is half into sum of the parallel distances, parallel sides. Parallel sides means these two. AB is 1 and this is 13 by 3. So sum of the parallel sides are 13 by 3 plus 1 into perpendicular distance between them. So perpendicular distance means this, which is maximum on y-axis 4 into 4 plus area of SCD. It is like a triangular form, so half into base into height. Here base is SD. SD we calculated like 5 by 3. So half into 5 by 3 into, and what is height? This one. As it is a distance, only magnitude we are taking. So into 2. Here 2 cancels. Here 2 times it gets cancelled. And here 39 by 3. Sorry. 13 plus 3. That way we have to consider. 16. 16 into 2. 32 by 3 will come. Yes. Plus 5 by 3. which is equal to 37/2. So this is the option. And next, see, whatever the concepts we have discussed, all previous questions are based on that concepts only. So you must look into those type of problems. Next, speed versus time graph for a particle is shown in the figure. The distance travelled by the particle during the time interval t equal to 0 to t equal to 5 seconds. So here to here we need to find. So the area formed is like a triangle. So here we can take area under the graph equal to distance travelled. So what is the area under the graph? Like half into base means till 5 seconds now. So 0 to 5 into height. This is the maximum height. So we can take it as 80. 2 4s are 4 into 5. So the distance is 20. Okay. So 0 to 5 seconds we are asking. So that is what we have taken area under the graph. Next, if a body loses half of its velocity on penetrating 3 cm in a wooden block, then how much will it penetrate more before coming to rest? So there is an object which is penetrating through a wooden block. Let us say it travelled initially, its initial velocity, let us say u, penetrating 3 centimeters, and here its final velocity, then they are saying body loses half of its velocity when it penetrates to 3 centimeters. So this, after travel this distance, final velocity is being loses half of its means u minus u by 2, then it will become u by 2. So in this case, in the first case, what will be the acceleration we follow, and they are saying how much will it penetrate more before coming to rest. Let us say further distance travelled is x, this we have to find. Here if it comes to rest. So here it is coming to rest. What is this further distance travelled by that body? We have to find. So we divide that into two cases, like first initially with this distance, with this initial and final velocities, use the equation v square minus u square is equal to 2as. So with that acceleration, finally it comes to rest. Then you can find the x. So v square means u by 2 whole square minus u square is equal to 2a into, what is the distance travelled with this is when it loses half of its velocity means 3 we substitute. So from this a value will be equal to, here we get minus u square by 4, 2 will come this side. So it will become u square by 8. Means here we get 4 minus 4 u square, 3 u square will come, 3 cancels, finally minus u square by 8. This is the acceleration. In the second case, when it travels this much distance, this will be initial velocity and this is the final velocity. So initial velocity you take it as, final velocity is 0 using the same equation. Initial velocity is this one. So from here it moves with this velocity, slowly velocity decreases. Velocity decreases means here we are getting retardation. So minus u square by 2, that is equal to 2 into minus u square by 8 into x. This x only we have to find. So here 2 cancels 4 times. Now u square by 4, u by 2 whole square means u square by 4 only. This cancels. So finally minus minus also cancel. X is equal to 1. So by using equations of motion, this is the question about motion with uniform acceleration. So see here, when it comes to rest, we got the acceleration as negative. That is the case retardation. Yes. Next, this is about the relative velocity concept discussion. A passenger train of length 60 meter travels at a speed of 80 km per hour. Another freight train of length 120 meters travels at a speed of 30 km per hour. The ratio of the times taken by the passenger train to completely cross the freight train when they are moving in the same direction and in the opposite direction. So what is the time taken the passenger train to completely cross the freight train? So here the time taken, both it is traveling 80 km per hour. Another train is at 120 meter travels at a speed of 30 km per hour. So initially when they are asked to moving in the same direction, time will be equal to the distance travelled by this train to cross the freight train. This much distance it need to travel. So that is the x by v minus u. Okay. So means we need to take 80 passenger train cross the freight train by traveling this distance. So it will be, so when they are in the same direction, we got the relative velocity is like Va minus Vb. So we follow in the same case. And the next case, when they are in opposite direction. So let us the passenger train travel the distance, let us say it is x, we take it as 120 again by v plus 2, because they are moving in opposite directions, this like this. So one will be, if it is first train speed u and second train speed v, it is plus and it will be negative. So v minus of means we need to consider like v and v, because we are taking the first train is v in the formula given that way. So as per whatever the directions initially you have chosen, so till the process completes, maintain the same sign convention. So now we can find the time taken when they are moving in the same direction, that is 120 by 80 minus 30, which is equal to, so 120 by, let us say the distance, let it be in both the cases it is same only. So you can keep it like x only by v minus u means 50, and here like 120 by 80 plus 30, like 120 by 110. If you take the ratio, we get 110 by this cancels, we get 110 by 50. So answer is 11 by 5. Next, an automobile traveling at 40 km per hour can be stopped at a distance of 40 meters by applying brakes. If the same automobile is traveling at 80 km per hour, the minimum stopping distance in meters is. So an automobile traveling initially at 40 km per hour, it can be stopped, means its final velocity becomes 0. At what distance after it travels? 40 meters by applying the brakes. If the same automobile is traveling at 80 km per hour, the minimum stopping distance in meters is. So in the second case, same automobile U2 is being 80 km per hour and it comes to rest, and what is that stopping distance we have to find. So stopping distance, it moves with that acceleration only when it comes to rest. So by using v square minus u square is equal to 2ax. Here we can find a value. Yeah, the same a value we can substitute here, can find the s2. So students, this is the required discussion. So you can follow the same concepts and practice for exam well. So here I am giving you So few questions to do work. You can solve and post your answers in comments. So just follow these questions. I given 3 questions. So follow the concepts and finish them. Thank you, students.